Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy. Academy is for you to take the right decision, to move in the right direction, and to reach at the right destination. Hello Ram, in this lesson, we aim for becoming the aware of how to create the lattice structures between any given two surfaces. Okay, for example, if you want to infill the gyroid lattice or stud based lattice or any other kind of lattice for your applications such as lightweight applications, heat exchanger applications, like porous medium type. So between any given two surfaces. So in that regard, how can you use this nTopology software and you can able to create the infill lattice between a given two surfaces. Okay, so I will going to explain you and I will going to show you what are the steps included, and what are the input parameters we need to give, and we need to define each of them, and what are the ranges between them we need to give. So I will show you how to do it, all these things. So here in this lesson, our main objective is to infill the create the cell maps, create the cell map between any given two surfaces. Once we have prepared the cell map, we can able to we can easily create the lattice structure within that given cell map using periodic lattice, as I explained in the previous lessons. So if you want to know about that, you can go through them. Okay, so let's begin. Before creating that, we can give the name of the file as like infill infill lattice between between CAD surfaces, CAD faces or surfaces. Okay, and we can give the description as the generation of the gyroid lattice between two two CAD 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 surfaces. Okay, yeah. Then we can label the section name as CAD surfaces, lattice between two CAD faces. Okay, yeah. Here we need to know about how can we get the that particular cell map. So as I said that, so to get the cell map, we can go to lattice tab. Later that we can, here we have the lattices, and here we have the different types of unit cells. Here we have the cell maps. From here we can select today's cell map. It is about the cell map between CAD faces. Do we found that? Do we find that? Yes, here it is, isn't it? What it is saying? It is saying that we can construct volumetric lattice cells between CAD two CAD faces, isn't it? So here uh, we have the CAD body where it has a two CAD faces, Within that two CAD faces, we are going to construct the volumetric lattice, because our CAD itself a volume. It has some length, width, height or radius, whatever it is. So in that particular volume, we are going to create the lattice. So let's begin. Let's select this. As I said, we can select this particular CAD cell map between CAD faces, cell map between CAD faces from here, or we can also find it. We can also search that particular CAD faces, isn't it? Cell map. Cell map. Just type the keyword cell map. We can get it from here as well. Cell map between CAD faces, as well as here also we have the cell map between CAD faces. So let's delete one of them. Yeah. Now after selecting this, what do we observe? Here there are four input parameters we need to define. One is, as our target is to create the lattice, volumetric lattice between two CAD faces, so we must provide two CAD faces, isn't it? So here we have to provide the CAD face 1 and second CAD face, and after that we need to mention how much quantity of the unit cell we want along U direction, along V direction, along W direction. I will show you. And do we want to maintain linear or do we want to maintain curve? So it is up to us. If you want linear, then you can check it, or if you only want curved one, then you can uncheck it. Okay, the main important till now, we want these input parameters from CAD body. So do we have CAD body now? We do not have. Then what do we need to do? We need to bring the CAD body. How can we do that? We can get it from importing the CAD body. How can we do? Either from searching. Let's select import keyword, just type import part, isn't it? Import part. From here we can get it, or we can also get it from utilities tab. From ribbon, from utilities tab, here exchange option is there. From here we can either export the part or import the part. Let's select the import the part. So these two are same. So in these two ways we can import the part. Let's delete one of them. Now from what do we observe here? Here we can select the part from given path. So let's select that part. Yeah, here we have the rim, isn't it? So let's select this. Yeah, now we can make it as Z. Simply press the Z and give the isometric view. Okay. Yeah. Yes. So this is our CAD body, isn't it? So here we need two faces. So let's here face means what? This is entire one our CAD body. So once you uh, come to near the face, so face automatically highlighted, even edges also, isn't it? Even if you see this, if you go to near the vertices, even vertices also going to highlight. So we can make them as a variable independently. So I will show you how to do them. Let's press the Z. Yes. Now we want to convert. We want to like your CAD faces, isn't it? We need CAD faces. So let's select this CAD face and just right click there. What do we observe here? We can create the CAD face, create CAD face variable, or create implicit body from CAD face. So let's select the create CAD face variable because we want CAD face only. So let's create this and label it as, rename it as face 1, face 1. Okay. Now we need to select the CAD face exactly opposite to it. Otherwise, it is very difficult to create the lattice. You cannot select this. So let's select its opposite. Exactly opposite one is this face. So is this highlighting or not? It is highlighting. So let's right click there and select the create CAD face variable. And we can give the rename as face 2. Okay. Yeah. Now we have created the two faces, isn't it? So now just simply minimize this. We have created now two faces, isn't it? Here we are able to see them. Now let's place this face 1 in first phase and phase 2 in second phase. We can do one thing. Let's place this before and also place this, sorry, here and here. Okay, so that we can maintain the flow. Here we can give the add a comment also. Created created the faces. And see, let's place this before because first we have to be imported now. Give the comment as imported the part, CAD part, rim CAD part. Okay. Yeah. And here we can modify it as created two opposite faces. Okay. Now we can add the name as creating created created the cell map. Okay. Now till now I think I hope you understood. So let's give the UV count. So along x direction, along y direction, along z direction. So U belongs to x direction, V belongs to y direction, W belongs to z direction. Let's give the count as 5, 5, 5. Okay. And let's see what is going to happen. Yeah, have you seen this? Now the cell map is filled between the created two surfaces, isn't it? So this is how we can able to create the cell map, volumetric cell map between any two opposite faces. Okay, first here we need to create give the two different faces which must be opposite to each other, and we need to give the UVW count along x, y, z direction. You can see also here this red line indicates, have you seen this? Here if this coordinate is starting from here, this red line is indicating along this edge is u direction, and this green line indicates the v direction, and this blue line indicates the w direction. So if you want to increase the unit cell count, for suppose we can increase along u direction, then now this you can simply observe here only. Okay, let's see what is going to happen. See, have you seen this? So like that we can refine that. Let's give the 20. Have you seen this, how exactly perfect it is? If we uncheck this, what is going to happen? Now it is perfectly curved. If you give this, see, they are linear, you can see here. So here, see, you can see here, see, curved one, isn't it? So like that we can give the linear and curve. Now we have created the our cell map, even you can see. So like this we have created our cell map between these two faces. Even you can also give between these two faces, and even we can give between these two faces, and here also. So okay, I hope you understood till now. Here it is very simple. We initially imported the part and created two different faces and placed those two faces here in first phase and second phase, and we have given different UVW count. Okay, this is how till now we generated the cell map between the two faces. Now the most important thing, we need to create the gyroid unit cell between this unit cell. Okay, let's minimize this imported part. So have you seen this each block? Even we can minimize the faces also. So have you seen this? So this each block filled with our given our defined unit cell. Okay, let's define that unit cell. How can we do that? As I explained in previous lessons. So for that we need to create the periodic lattice. So we can get the periodic lattice from lattice tab, and you can go here. Here we have various type of volumetric lattices. So as we said that rectangular, cylindrical, spherical. So let's select the periodic lattice. Okay, we can add the comment as well, like created the periodic gyroid lattice. Gyroid periodic lattice. Okay, yeah, here have you seen this cell map? So here we need to define this, the defined cell map. Okay, so let's hold this. After holding this, it is automatically highlighted, so it is suggesting us that you can place that cell map here. So let's place this. Now we have placed that. Okay, now we need to define the unit cell by unit cell, and the respective thickness of that unit cell. Okay, so let's define the unit cell. Here we have different types of unit cell, graph unit cell, and TPMS unit cell and wall TPMS unit cell. So let's select the wall TPMS unit cell. Okay, here again we need to define various type of unit cell. What type of unit cell we need to select? Even graph, even wall TPMS unit cell is itself has six different types of unit cells. I can show you here. Have you seen this? Yeah. So it is up to you which unit cell you want. So let's select the gyroid unit cell. Yeah, so this is our gyroid unit cell, and we are going to place this gyroid unit cell within this cell map as we defined different UVW unit cell counts. Okay, let's give the thickness as a 0.1 mm, and then let's see what is going to happen. Now it is showing that it is generating. Okay, 99% building lattice view. See how beautiful it is, isn't it? So we have generated our gyroid unit cell based volumetric lattice, periodic lattice within two faces. Okay, here we have two different faces, isn't it? Now you can see this, but there is some damage in the surface. How can we modify that? We can simply enhance the thickness. Okay, so that we can get the beautiful gyroid unit cell, gyroid lattice structure. So let's see, we are waiting for that. See, this time the surface is smooth and it is beautiful. There is no any damage. Okay, so like this, even they are perfectly generated with porosity, with voids, and with volume connectivity. So let's see its beautiful structure by pressing Z. Yeah, this is how we generated our gyroid lattice between two CAD face. Okay, yes, you can just, even you can see with respect to the given CAD model. So you can also fill here, you can also fill here, you can also fill here by selecting two different faces. So if you want to give with respect to only one face, I already explained you can select the cell map of single CAD face. So that you can do here, because here we have only one face. So that you can do, I already explained you. So even you can do here also by using select, but it's something different. Okay, but this is only for two CAD faces. As we have in this CAD geometry, we have two different faces where they are in opposite direction. So that condition we must fulfill. Okay, then only we can able to. Here we have one face, and here you have one face. So there it is difficult to generate the particular gyroid lattice or any other lattices. So this is how we can able to generate the our lattice. Even just let's minimize this, and even let's minimize the faces as well. And if you want to see the cut view, we can just simply press this and press the Z. Let's uh, yeah, here it is. Why there is a difference? Yeah, just bring it there, and even we can bring this here. Yeah, have you seen this? You can able to see the our respective lattice structure, how exactly beautiful it is. See, so if you want further higher relative density, then you can simply increase the thickness, and it is up to you how to do that, how much you want. So this is how we can able to design the gyroid lattice within defined two CAD faces. So till now, I hope you understood what we have done. So initially we imported our part, then we created their respective faces, and then we also created the cell map. Let's make it variable. So this cell map we have created using two faces and count different counts. Now it is up to you how much count you want to give. You can play with them based on your research work, or based on your industry work, or based on your application. Now then we have defined the, let's place this because it is here. Yeah, we have created the periodic lattice. There we have defined a different type of unit cell, like we have designed the gyroid. If you want to see that diamond, you can also play with that. Let's wait. It is generating. See, see. So diamond unit cell is generated with respect to the given the defined CAD faces. I hope you guys okay understood about this. Just press the jet. Yeah, see. Okay. So with this, I hope you understood. So it is very simple. Now you can play with the parameters, and you can use this particular cell map based on your geometry, and you can create the respective cell map. Okay, with this I'm closing. So if you have any doubt, please let me know. I will try to explain them. I'll try to clarify them. So let's meet on next lecture. Thank you.